at all?
Yeah. Yeah, I did a good amount of them. There's a couple that I couldn't get, and
Okay.
there's like two of them that I couldn't see properly.
Okay. Before we leave logarithms, we're pretty much done with logs. And I'm
Yeah.
relatively pleased with how you've learned them, aren't you? I mean, it felt to me like last session you had it figured out.
Yeah.
Okay. So which of these couldn't you do?
I couldn't see number 50, so I wasn't able to do that because the first part of it wasn't
Okay.
readable.
That's fine.
Um,
What
I
number
didn't.
what number 50 says is log base 5 of this equals log base 5 of 3x,
Oh,
which
so
means,
that would just be x equals 15.
yeah, x equals minus, no, you're right, x equals 15, correct. Okay. Which other one gave you trouble?
Um, 58 and 59,
Okay,
but that's it.
let's have a look.
Or 57 and 59. I apologize.
I'm sorry, what?
57 and 59.
57 and 59? Okay.
Yeah.
It's the first step.
Raise everything to the fifth power.
No, this is 6.5. Okay, remember what our goal is. Our goal is to isolate that.
Divide both sides by 6.5.
Correct. So now we have log base 5 of 3x equals this number. What's the final step when you're trying to solve log equations?
You want to get rid of the log, right?
Correct. You want to get them in exponential format. What is the exponential expression this is equal to?
5 to the 20 point over 6.5 power equals x.
Equals 3x.
Oh, yeah.
Okay, so now I have to divide both sides by 3, and that's my answer. And you can plug that into a calculator. Okay, in other words, if you want to know what 5 to that power is, that's a number you can get off of a calculator. Approximately 5 cubed. 6.5 goes into 20 about 3 times, but it's 3 and change, or it's 2 and change. But there's your answer. In other words, as long as you end up with an answer that you can get out of a calculator, that's what's important. None of these, I suspect, are going to be problems that you can solve without a calculator. And 59. What can I say based on this?
You could cancel out the natural log and you just have ones outside.
Yeah, so this argument is equal to this argument. And now, is there any problem solving that?
No.
Okay. In other words, you're going to gather your x's on one side, your numbers on the other, and divide both sides by the coefficient of that x. Okay. I thought what we would do tonight is talk about something that's actually kind of similar to logs and exponents, but you tell me, and that is powers, roots, and radicals. I'm not sure exactly. In other words, when we first started working, I know you're going into pre-calc and you wanted refreshing on logs and exponentials. Do you need refreshing on powers, roots, and radicals?
I'm not sure I remember what radicals are.
Let me ask a few basic questions, and we'll find out whether or not you need refreshing on it. How do I solve that?
You could do a factor tree if you wanted, but you'd have to take out as many pairs as you could.
Okay, yeah, I didn't mean how to solve it. I meant, how do I simplify it? So, what's the first step? In other words, I'm going to break that up into the product of two radicals.
You could do 2 and 16.
Good. I'm going to do the 16 there and the 2 there. And now what?
You could do 4 and 4.
4 root 2. That's the answer. Okay? In other words, as long as you factor it into two numbers, one of which is a perfect square, then you can go forward. For example, let me think of one. Yeah, let's talk about the square root of 12. Well, I could say that that's the square root of 6 times the square root of 2, correct?
Mm-hmm.
But I can't do anything with either of these. And so I haven't made it simpler. I've made it more complicated.
Wouldn't it be 2 root 3?
Yeah, it would be, but in other words, my point was I'm trying to figure out when I factor it, I want to make sure one of these numbers is a perfect square. Otherwise, it doesn't do any good to do it. In other words, root 6, root 2 didn't help me. But root 4, root 3 helps me because that turns into a positive number. Okay? All right, let's go on. What does this mean?
There'd be like a mini 3 on top of the...
It's a cube root, yeah. In other words, whenever you express a radical in a fractional exponent format, then the denominator represents the root, and the numerator, in other words, if I put a 2 in there, then it would be 8 squared. Okay? What does this mean?
Uh, 3 square root 8 to the negative 2 power.
Okay, what's the implications of the minus sign? Let's get rid of it first.
Wouldn't you move it to the bottom?
Yeah, if I want to write that expression without a minus sign, what do I do?
You'd move it to the bottom.
So it's what?
It would just be 1 over 1.
1 over 8 to the 2/3. In other words, you were correct. You move everything under the number 1. Okay? And what is 8 to the 2/3 equal?
It would be a 3 on the outside and 64 inside the square root.
Well, let's always do the denominator first. What's the cube root of 8?
Cube? 2.
Right. In other words, that's what that 3 means, is the cube root of 8, and then we're going to square that answer. Well, notice that if we do the cube root of 8 first, we get 2. 2 squared is 4. Whereas if we do 8 squared, that's 64, And now we've got to take the cube root of that. We still get 4, but we have to deal with bigger numbers. So when they give you problems like this, always do the root first. It'll make the problem so much easier. Okay, let me bring up my book. See what else I can find to challenge you. Write this in fractional format. Fractional exponent format.
It would be 5, and then the exponent would be 3 over 4.
Okay, do you know how to find that in your calculator, that answer?
Yeah.
Okay, in other words, you're going to raise it. You can either raise it to 0.75, which is actually the easiest thing to do, or you can raise it to that, and it'll give you the proper number. I usually convert it to a decimal because then I don't have to use parentheses. If you're going to put it in fractional format, in other words, if I'm going to say 5 raised to this, I've got to use the parentheses. But if I don't want to use the parentheses, I could just put 0.75 down there. A little faster. Okay. How do we solve that?
X cubed minus.
What's the best first step?
To distribute the exponent?
No, actually not. That'll just make it harder. In other words, if we do that, notice we'll end up with a cubic. And there's nothing tougher than solving a cubic or a quartic. In other words, if I said, if I give you a quadratic, you can solve that, right? You can either factor it or you can use the quadratic formula, and you can come up with 2 solutions. But if I give you a cubic, and this is what you'll learn when you get to pre-calc, that is tougher than nuts to solve. Surprisingly, who knew? It is. There's no such thing as a trinomial. In other words, there's a quadratic formula, but there's no cubic formula. Okay? There's no formula you can plug in A, B, C, D, and D here to come up with the solution, assuming this was all equal to 0, of course. In other words, we almost always try to solve these by setting them equal to 0, and by setting them equal to 0, what I'm asking for is what are the x-intercepts, okay? So just so you know, solving cubics and quartics is really, really tough. It can be done, but each problem is about a 20-minute problem, okay? So, given that we know that, the first step is not to expand this. That'll just make it a hard cubic problem. But there is a relatively easy first step. Remember, I'm trying to isolate x. Well, I can't isolate it yet, but how can I isolate x minus 2?
You could.
What is this? If I exponentiate both sides to the 1/3 power, what am I left with on the left side?
Just x minus 2.
Exactly. In other words, because it was being cubed, I wanted to take the cube root of both sides. And I can leave this as that for the moment. Now I add 2 to it, and there's my answer. Is it plus or minus 10? Or just plus?
Would it just be plus or minus?
It's just plus. Just plus. In other words, the 8 to the 1/3 is equal to 2, but minus 8 to the 1/3 is equal to negative 2. So this is not a plus or minus, because minus 2 times minus 2 times minus 2 does not equal 8. It's only even roots that are plus minus. In other words, if I have 16 to the 1/2, that's equal to the square root of 16, which is equal to plus or minus 4. But let me go back a second. I don't want to confuse you by writing it like that. Let me put this in the form of an equation. X squared equals 16. Now, in order to solve this, I have to take the square root of both sides, which is the same as exponentiating both sides to the 1/2 power. Okay? That leaves x over here, but over here it leaves plus or minus 4. Whenever you are taking an even root, whether it's square root or 4th root or 6th root, the answer is plus or minus. In other words, now, why did I not want to write it the way I originally wrote it? If I put this, that's actually equal to plus 4. Okay? Only it's the same as anything else. If I'm writing the radical sign and I don't put a sign in front of it, it's assumed to be positive. If I want the minus 4 result, then I need to write minus root 16, and that's equal to minus 4. And that's just by convention. Okay? In other words, that's just something math people have decided, that if there's no sign in front of it, we're going to assume it's positive. Just like all numbers. If I don't put a sign in front of that number, you assume it's positive. Well, what's the difference between that and when do we get plus or minus? We get plus or minus when we're solving an equation where we have to take the square root of both sides. Okay? And I write it like this and not like this because that assumes the plus square root of 16. So you pick up the plus or minus when you do that step where you take the square root of both sides. That's where you always have to have the plus or minus. And that is a very common mistake and a very bad mistake. You will not get the answer right if you leave off the plus or minus. If you happen to make a mistake and leave it off. Okay? Because frequently it's things like, well, it's x minus 2 is equal to that. So now the proper answer is 2 plus or minus 4, which gives me two answers, 6 or minus 2. If I want both answers, I've got to include that in it. Remember, this came from that step. And it's a quadratic. You would expect there to be two answers. Most quadratics are going to have two answers, just like a linear function has only one answer. All right.
X would equal -4.
Correct. And only -4. I mean, if you want to be precise, we'll take the square root of both sides. We'll even say that that's equal to plus or minus 0. Well, subtracting 4 from both sides, you get -4 plus or minus 0. You can forget that. So in this case, we got only one answer. But you'll learn in pre-calc that we got one answer with a multiplicity of 2. All quadratics are going to have 2 answers, and this is a quadratic. It's just that we've got one answer, but there's something called multiplicity associated with some of the answers also. And that was one of them. Okay. Evaluate these without using a calculator. And you know when they say you can't use a calculator that it must be a whole number, right? It's not going to end up being an irrational number because you would have to have a calculator to give them that answer. What number multiplied by itself 3 times equals -1,000?
-10.
Correct. And again, it's only negative because we're taking an odd root. When you take odd roots, you either get a negative or a positive, but not a plus or minus. I'll get beyond these quickly here. Again, what's the 4th root of 256? Knowing it's going to be a whole number?
Isn't it 4?
Okay, so what's my answer?
Plus or minus 4.
Very good. I was just sitting here trying to figure out, is that going to be plus or minus 4? Because what we end up with is the negative isn't affected by that 4. So I got a negative, but then when I go to figure that out, it's plus or minus 4. Okay, now when I throw that negative in with the plus or minus, it turns it into minus or plus, but that's the same as plus or minus. So that turns out to be the right answer. All right, enough of those. Let's go to properties of rational exponents. Is that equal to? One second, Isa. Hey, Dan. Sure. Oh. Okay. I'll do that. Sorry, Isa. Okay, I'm back.
That's fine.
What was the result here?
5 to the 1/6 power.
What do we do when we multiply the base? What do we do with the exponents? In other words, if I had 5 to the x times 5 to the y, what's that equal to? We don't multiply the exponents. We always do one less level mathematically. In other words, if I'm multiplying the bases, I'm going to add the exponents. So this one up here would be 5 to the 3/4. Okay? There's three basic rules. There's to the x times b to the y. That's equal to b. It's a lot like logarithms. And why? Of course it is, because logarithms are exponents. So I'm dealing with these exponents. And logarithms, when you take the log of a times b, it's the same as the log of a plus the log of b. Okay? If I have division going on, what's that going to equal to?
Isn't it base of b x minus y?
Yeah. Notice that subtraction is one level less than division. So the most important thing you can remember is you don't do to the exponents what is being done to the base. These bases are multiplying. These bases are dividing. And finally, if I have b to the x all to the y power, something I call double exponentiation, what do I do here with
It would be b, and then the exponents would be multiplied to be x.
Correct. In all three cases, you're doing something different to the exponents than is being done to the underlying base. So, I'm going to leave those rules there for a moment, and I'm going to write on the right side. Tell me what this would become. Hold on. You know, there's one rule I didn't write over here. Call that rule 1, that rule 2, that rule 3. And let's talk about if I have different things. In other words, if I have AB.
Wouldn't it be 8 to the 1/4 power?
No. In other words, these three rules apply only when you have the same base. Okay? So I can't use these rules on this problem. I've got different bases. I have 8 and I have 5. But because of this rule over here, I can turn it into 8 to the 1/2 squared times 5 to the 2/3. Or 5, let me write it the same format, basically. 5 to the 1/3 quantity squared. See what I've done? I've merely separated them. Okay. Now I can apply rule 3. What's 8 to the 1/2 squared? Multiply those two exponents.
8 to the 1/4 power multiplied by 5 to the 1/6 power.
2 times 1/2 is not 1/4. What is 2 times 1/4?
That would just be 1.
Right. So that just turns into 8 times
multiplied by 5 to the 2/3 power.
Correct. And there's your answer. And that's not a whole number, so I don't mind leaving the answer just like that. That's actually a good way to leave the answer. That's the most perfect answer you can leave. If you turn it into a decimal, it becomes an approximation. What is
Base would be 7 and then 1 minus 1/3.
What's the exponent?
So it'd be just 2/3.
Just 2/3, exactly. Oh, 1 minus 1/3 is what you said. Yeah, I'm having a little hard time hearing you. But yes, that's...
Yeah, your voice is lagging.
Okay, how about this one? And again, if we look back at those rules, there's one last one on the left. If I have A divided by B and the whole thing is to the m, then I can say that's the same as A to the m divided by B to the m. So those 5 rules will handle each of these problems.
It would be 12 to the 2/3 power and 4 to the 2/3 power.
Well, unfortunately, that doesn't look very pretty. Well, there's nothing wrong with doing that, but we still have to simplify it.
You could divide the whole thing by 4.
Right. In other words, here's our A, here's our B, so we know that that's equal to 12 over 4, all to the 2/3, or 3 to the 2/3. So totally simplified becomes that. Okay. Notice you don't get very far if you try to take the cube root of 4. That's an irrational number. Same thing with the cube root of 16.
Wouldn't the answer just be 4?
How'd you get it?
I multiplied the square roots together since they have the same outside base.
The cube.
And I got 64 and then
the cube roots. Right. That's a cube root. Okay? And you're correct. Now that we multiplied 4 times 16, we can take the cube root of 64. That's 4. Notice how much better that answer is than this one. How in the world do I come up with 4 there unless I multiply 4 times 16 and take the cube root of the answer? Fourth root. Divide the 2 numbers under the radical sign first.
So 161 doesn't go out evenly though.
Excuse me. I think I wrote it. It's 162. My apologies. No wonder you were.
It'd be 2. No.
81 is what 162 divided by 2 is. What's the
81.
4th root of 81?
3 would be the answer.
Yeah. Now notice the answer is not plus or minus 3. And the reason is that when I wrote it like that, I was implying that it was a plus. Same thing with that one. So that's automatically a plus. You don't pull out plus or minus. I mean, you don't get a plus or minus when you have a radical sign. You only get it if I would have written, in other words, these two things aren't precisely equal. If I write that like that, that is plus or minus 3. All right, let me go on here. What is
Wouldn't that just stay this?
how many root 2's is this?
Just 1
Okay, how many root 2's do I have here?
or 2?
When you add 1 to 2, what do you get?
3.
3. In other words, think of these as being apples. My apple is equal to a root 2. So I have 1 apple plus 2 apples equals 3 apples. And I can only add them together if they're the same thing. In other words, if I change that to a 3, I can't do anything with it. I cannot add a root 2 to a root 3, at least not without converting them to decimals. In fact, if this was your answer would look like this. Only same things can be added or subtracted. You can multiply. What's this?
It'd just be square root of 6.
Correct. All right, let's look at some variables. What is the square root of x to the 4th?
X squared.
Okay. What is the square root of x to the 6th?
X cubed.
And what is the cube root of x to the 6th?
X squared.
Good. So the problems that you're going to see are of the following kind. Fourth root of x. Hold on a minute. Let's go back a step. Let me make sure you know how to do that. What's that equal to?
X square root x.
Almost. X fourth root x. In other words, you're right. I can bring one complete x out. That takes away 4 of those. But what's left is still the fourth root. It does not turn into the square root. In other words, that's the way it would look. I could also write the whole thing as x to the 5/4, but when you're pulling a variable out, you pull out whatever multiple. In other words, there's one multiple of 4 in there with 1 left over. If that was a 6, then that would be 2. Okay? And in fact, the fourth root of x squared could be changed to x times the square root of x. The fourth root of x squared is the same as the square root of x. Okay. So if I had a problem like, all right, let's get a little harder. do numbers and variables one at a time and finish one before you go to the next? What's the number?
Well, first, wouldn't you have...
What's that?
First, wouldn't you have to take the z to the negative fifth to the top?
You can do that. That's not a bad first step. I like it. There's lots of first steps that work, but that's not a bad one. Okay, now what? When I say handle the numbers first, do that part.
Then you'd simplify the numbers, so it'd just be 3 at the top, and the 2 would be 1.
Now do that part.
And then wouldn't the top for x just become x 2/3?
Correct. In other words, there's a hidden 1 right there, and you're going to subtract the exponent. So it's going to be 1 minus 1/3, or 2/3. There's no y in the denominator, so we don't do anything with that. There's no z in the denominator anymore, so we don't do anything with that. Usually in problems like this, they do not like negative exponents. In other words, they would not like this answer. And when I say they, I mean probably your teacher. Usually they'll give you instructions. Leave your answers without negative exponents. So this would not be a particularly good answer. It would be a technically correct answer. But it's kind of like leaving... In other words, it's a similar thing as leaving an irrational number in the denominator. In other words, if I had this, I would never turn that in as an answer. Although, interestingly enough, on Wolfram Alpha the other day, I was doing a problem and the answer was given as this. That was the answer. I couldn't believe they gave me an answer with an irrational denominator. In other words, they didn't rationalize it. You know what I mean by rationalizing it?
Yeah.
How would I rationalize this one?
You'd have to multiply the top and the bottom by negative square root 3.
Not a negative, just a square root of 3. And now what's that give you in top?
2 square root 3 over 3.
Right. And that's the same number. If you put that into a calculator and put that into the calculator, you'll get the same answer. What's this? That's a b.
B, 5 root b to the 4th.
Okay, you got to be a little careful when verbalizing that. And you know, one of the nice things about online tutoring is you kind of get a chance to learn how to verbalize stuff properly. You said b4 b to the 4th, okay? That's why I can't say it like that, because that's the way I would write it based on the way you said it. The way what it is b times the 5th root of b to the 4th. That's the way I would say that, is b times the 5th root of b to the 4th. I could also say b times b to the 4/5. It's another proper way to say it. But don't use the word square root when you have a radical sign that is not square root. In other words, if it's a radical sign that means cube root or 4th root or 5th root, say that. Okay, here's that. Cube root of x over y to the 7th. We could do this the traditional. let's do it the traditional way that we've learned. In other words, separate numerator and denominator.
It would be just x minus y to the 7th.
Well, it's cube root of x over cube root of y to the 7th. And now that becomes cube root of x. What's the bottom become? What's the cube root of y to the
y squared cube root y.
Y squared cube root y? Is that what you said?
Yes.
Okay, cool. Now notice what's wrong with that. I'm going to have an irrational bottom if y is not a perfect cube number. Okay? So there's a little trick that isn't taught that much. I see it in this book, and I'm going to show you how to do it, and it will avoid having this happen. Well, first of all, let's talk about how we handle this. What would you do if I gave you this as an answer? How do you rationalize that?
I would multiply the top and bottom by third root y squared.
Or y to the 2/3. In other words, our goal is to turn the bottom into y, not any radical sign. Okay? And you don't multiply it by y to the 1/3, because that would give you y to the 2/3 in the bottom. But as long as I multiply the bottom by y to the 2/3, I'm going to add the exponents, and I will have rationalized the exponents. Now, let me show you the trick the book does to get around this. They first of all take the attitude that they want to turn the bottom into a perfect cube. Okay? So they don't end up with an irrational denominator. Well, how can I turn the bottom into a perfect cube right off the get-go? I can multiply top by y squared, bottom by y squared. Now, I have the cube root. Go ahead.
Never mind.
Okay, now I have the cube root of x, y squared, all over y to the 9th. Now you'll notice that's going to solve my whole problem, because the top is going to be this, and the bottom will come out to be y cubed. And that's what we got before also. In other words, when I rationalize the bottom, before we had y to the 1/3, remember I had to multiply it, well, we had a y squared times a y to the 1/3. In other words, if you do the problem the normal way, you end up with y cubed in the denominator after you rationalize it. So it's not necessary to take this creative step early. It does kind of make it a little cleaner. In other words, notice that when we turn the bottom into a perfect cube, y to the 9th, the problem kind of solves itself in one step, and you only need one more step. But when we did it without multiplying that, we got cube root of x over y squared, y to the 1/3, and then we had to multiply the top and bottom by y to the 2/3, and we get the same answer. In other words, we still get the cube root of x, y squared, all over y cubed. So even if we do it our way, the first way we did it, we get to the answer pretty quickly, as long as you know how to rationalize that, y to the 1/3. How would you rationalize this? I got this on a problem once, and I didn't know how to do it. That's an irrational number. because y to the 4/3 could be written y times y to the 1/3. But if somebody said rationalize that, what would you do?
Multiply the top and bottom by y 2/3.
Correct. In other words, you rationalize it. You don't turn the bottom into y, but you do turn it into a number that's guaranteed to be rational, which is y squared. In other words, when I add these two exponents, I get 6/3. So that's how I would rationalize an exponent greater than 1. Is to turn it into y squared instead of y in the bottom. All right, let's see. That's probably a good place to stop, Isa. Give me a couple of minutes to get your brother on the line. But yeah, does this seem like where we should be?
Yeah.
Do you have any materials that they've given you as to what you need to review to be prepared for pre-calc?
No, they really haven't.
Okay. It's just you suggested logs and exponents because you felt that was an area of weakness originally?
Yeah, because my last tutor just confused me a bit on it.
Okay. You feel good about logs and exponents now?
Yeah, definitely.
Good. Good. All right. Well, I'll keep on, and we'll talk about composite functions, inverse functions, stuff like that in the next session. Okay. I'll see if I can find some homework problems, just a page of them, and I'll send them. I'll email them to you just like I've been doing.
Okay.
Okay. All right. Have a good week. I'll talk to you next week.
Bye. Bye.
Bye-bye.